All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to continue learning Godot with Rust. Today, I'm probably not going to do a yap session doing the before getting into the Godot stuff because, dude, I put way too much faith into my system, um, thinking that I'm gonna, even if I become late and I decide to start the stream, I'm gonna immediately be able to start the stream. And I don't know, half an hour back. I mean, okay, I was supposed to start the stream like 2 hours ago, I think. Two or maybe 1.5 hours? 1.5 hours ago. I became a little bit late. And then when I finally managed to set the entire thing up, um, suddenly there was a that usual like weird behavior with my Windows machine. And uh, because of that, I had to restart the system. And then after restarting the system, it took some time to start up. And now finally, we are here. I'm probably only going to be able to stream for like 50 minutes, I think. Maybe not even the full hour. I don't know. But yeah, dude, I guess let's get into it. I need to get better about uh, about starting the stream on time. What happened is I got busy doing a social media post because I was creating a post about the what do you call it, that whole Rust thing, what I was talking about yesterday, where like I like the fact that yesterday I was mentioning how much I like Rust, and one of the reasons why I like Rust is because um, you have this you have this thing where you can combine the functionality from multiple different libraries to build something bigger. And that's not to say that you can't do that with other languages, but this is the first time that I've actually done it with a language, and that kind of makes me like Rust a lot and appreciate the Rust ecosystem. So what I was explaining yesterday was that, see, I said that I wasn't going to do a yap session, but here I am. But yeah, what I was explaining yesterday was that I wanted to create a tree map. I wanted to look into how to create tree maps using Rust, whether there are any libraries, any Rust libraries that help you create tree maps. And I found this library called TreeMap RS. It doesn't it doesn't do the plotting, but what it does do is get you to the point to where you have a tree map, where you have the objects that you want that represent that tree map. So basically, it can do the entire like tree map calculation for you, but the final rendering, the drawing of this tree map, the visual representation of this tree map, you have to handle that using a drawing library, and that's exactly what I did. I calculated the entire tree map using tree map RS, and then once the rects for the rects representing each of the map items were calculated, then I just passed those rects into a drawing function in TinySkia. TinySkia is what I'm using for doing the CPU rendering. Okay. So yeah, I was making a social media post about that, and that's kind of why I got a tiny bit late. And then there were a couple of other things that made me a little more late. Either way, I need to get better at you know not being late to stream. And I need to give at least like a half an hour window for any sort of possible technical issues. Otherwise, I'm going to keep getting late like this. Ideally, I would want to start the stream 3 hours before now. Like now, when I've started the stream, ideally, I would want to start the stream 3 hours earlier. And that way I could stream for much longer, but then usually that doesn't end up happening. Anyways, yeah, I've made that post, and now I'm ready to get back to practicing tiny skier. Messing around with the tree map thing was fun, definitely. I might actually make like a, I don't know, a simple wrapper function kind of thing to to make the drawing of the image much easier. Because, oh, actually, no, you know what? There is a library called Plotters. I could look into creating the functionality to plot this library using plot the library. What? To plot the map items, plot the entire tree map using plotters. I'm sure there's going to be some sort of function that lets you do, you know, custom drawing. So I can look into that, and maybe that way we can add tree map functionality to plotters. Because what I was planning on doing was use I was planning on using this I was planning on using this I was planning what am I saying? I was planning on using TreeMap RS and TinySkia together to create the thing that I'm trying to create. And that was gonna be like that was gonna be it. That was gonna be the entire project, and then I would upload it to GitHub. But then anybody who's using plotters, which I believe is a pretty big community. Hold on. And I remember I was exploring plotters before I had words. I was exploring plotters before I had gotten better knowledge and much more experience in Rust. Now I feel like when I look at the code for something, when I look at function signatures and the types that are being mentioned and all of that, I have a better idea of what I'm looking at. I know more about what I'm doing compared to previously. And so I feel like now if I got into plotters, then I would have a slightly better time with it. Um, Give me a second. I'm just opening up this GitHub page on my other machine. Also, I solved the problem that I was having with getting my Rust code to work in Godot. I think the problem was just because, okay, after I ended the stream, I booted up Ubuntu on this same laptop from which I'm streaming right now, and I set up a new project, literally just for this. I set up a new project, a new Godot project, new Rust project. I redid the entire setup with like the GD extension, I don't know, extension list, and creating like the boilerplate code and all of that stuff. And eventually, I got it to work in Godot, and then it occurred to me that there's a chance that this was not working on stream because I forgot to do cargo build. I hit save in the code and directly jump to Godot, but you have to build the library. You have to compile the code again because that library has to be loaded into Godot. It's not just the source code. So I guess that's what I was doing wrong because now I don't know if the tooltip pops up on stream. I don't think it does. how can I show, because I don't think this window pops up either, the create new node window. I don't think this pops up either. What I can do though is create it. Okay, give me a second. Yeah. So what I can do though is create the node and show you guys that yeah, this is the node. This is the player node, and its type is also player. And we can also see, I don't know how visible it is on stream because the Godot window itself, I've made it so small, but in the output window thing, it does mention hello world. So we know that the Rust code is running. Okay, now we can delete this. We can also delete this and come here. All right. Sorry, zoned out. Okay. Uh, yeah, we can get started with. Give me a second here. Yeah, you know what? Instead of writing the tree map RS functionality for what do you call it? For the thing is, okay, I could I could set it up in such a way that it pulls the library from GitHub directly because I don't want to use somebody else's code without them getting credit for it. Even within the code where like the code that I wrote, just so I don't forget, what I did is, do I have it here? Was it in this? I don't remember if it was in this. It's not in this, no. Um where where did I hold on. Where was it this? Hold up. No, it just says tiny Skia. Oh, yeah, no, I didn't install the thing. Yeah, I just remembered that. Let's go into source. There's just main. Where exactly was the project, dude? Learning term graphics? Oh, I think the project was on the other machine. Yeah, yeah, the project was it was on the other machine. Never mind. Anyways, my point was that um even in that code, because I just copy pasted the code, it was one library. The entire functionality was within that one library. So I just copy pasted that entire code and I made a module out of it in my own project, and I was then using the module. Um, I am gonna have to see how to go about, because I mean, yeah, I could just import this person's code. There wasn't any error in the code, but because the code was so old, so there were certain things that could be improved in it, and it was basically just Clippy complaining about stuff, or the Rust analyzer talking about certain practices and stuff. That was basically it. So what I could do is I could add this as a dependency, or I could do what I was doing before. What I did is I copied the entire code into a module file, And then at the top, I created a comment block, and in that comment block, I mentioned that credit to um, so and so, so and so. I mentioned the repo name and a link to the file. So I could do that. I could do that. Um, so essentially, code is just going to be my code is going to be writing um, a plotter using tree map rs. Yeah, that's what it is. My code will be writing a plotter using tree map rs, and I'll give the person, full credit um, in the code. So I don't think I'll be adding their code as a dependency. Yeah, yeah, yeah. Okay, all right. We only have like, I don't know, now from now we only have like 50 minutes. This sucks, dude. Like I need to get better at starting the stream early. I put way too much faith into my system that when I'm running late to stream, the system's not going to fuck me over, but apparently it fucked me over. Um, anyways, just a second. I am loading up my stream on my phone so I can look at the chat. Okay, all right. Yeah, let's continue with this. So yesterday we stopped at this point, which was here. Yeah, I don't think I ran this, did I? Yeah, yeah. No, I don't think I ran this, which is interesting. Actually, no, it's not interesting that I didn't run it. What's interesting is I also didn't add a script. The script field is empty on the node, but the node itself has custom functionality. I should look into that what that means exactly. Additionally, we need to let's bring this here. Additionally, we need to go through this. Oh, you know what I could do? I could go through this entire code where it's going to be explaining these functions. Yesterday, I was mentioning that I need to do more research on these functions like process and init, and I think physics process is the one that's used for physics. That's these are basically like update and fixed update in Unity. Um, yeah, yeah. So in this, we get up to this point. I need to look into how we are creating functionality here. So create a new script, attach script. Okay, attach node script window appears. It allows you to select the script's language and file path among other options. Change the template field from node default to object empty to start with a clean file. Okay, leave the other options set to their default values and click the create button to create the script. Then C# script names need to match their class name. In this case, you should name the file mysprite2d .cs. Okay, the script workspace should appear with your new sprite2d.gd file open, and the following line of code: extend sprite2d. Every GD script every GD script file is implicitly a class. The extends keyword defines the class this script inherits or extends. Okay, in this case, it's sprite2d, meaning our script will get access to all the properties and functions of the Sprite 2D node, including classes it extends like Node 2D, Canvas Item, and Node. With Sprite 2D extends Node 2D, Canvas Item, and Node. That's interesting. Okay, in GDScript, if you omit the line with the extends keyword, your class will implicitly extend ref counted, which Godot uses to manage your application's memory. Inherited properties include the ones you can see in the inspector doc, like our object's texture. By default, the inspector displays a node's properties in title case with capitalized words separated by a space. Okay. In GDScript code, these properties are in snake case, which is lowercase, um, with each word separated by what is hold on. Why am I having trouble reading? With each word separated by an underscore. You can hover over any property's name in the inspector to see a description and its identifier in the code. Okay, good to know. Hello world. Our script currently currently doesn't do anything. Let's make it print the text hello world to output to the bottom panel to get started. Add the following code to the script. Okay. Um, all right. Let's break it down. The func keyword defines, okay, all right, a new function. This is a special name for our class's constructor. The the engine calls init on every object or node upon creating it in memory. The engine calls init on every object or node upon creating it in memory if you define this function. Okay, GDScript is an indent based language. Okay, all right, cool, great. Save the scene as Sprite 2D if you haven't already. Then so and so, so and so. Okay, delete. I guess the only thing left to do is run this now, right? Oh, uh, in this in the GDScript thing, they haven't gotten to that point yet. Um, However, in our case, we have gotten to that point. You guys won't be able to see it on stream. I can just tell you that it's rotating. Yeah, it is definitely rotating. I need to figure out a better way to. Can you stop switching to this window, dude? Okay, yeah. I need to find a better way to. Actually, wait. Yeah, I need to find a better way to display the game view. I haven't figured that out yet. The problem is this, right? On on Ubuntu, on OBS on Ubuntu. Um, what was I saying? On OBS on Ubuntu, I use um, screen capture. I think the source is called. I use screen capture, and screen capture gives you two options. You can either do an entire display capture, or you can do an application capture. So in the case of display capture, it's just copying it's just capturing whatever is on your screen, and that has horrible performance. Actually, you know what? I should test that out compared to, though I feel like even if I'm only capturing two windows, I'm still gonna get better performance with these two windows than capturing the entire screen. I'm also a lot more comfortable with capturing the windows specifically and not capturing the entire screen, because when the entire screen is being captured, then I have to be careful about, you know, where I tab to and like what accidentally shows up in like the video feed. Um, yeah, the problem is this. Uh, I do an application capture. And that's great as long as the application is running. Once the application closes, it's not being captured anymore by that specific application capture, screen capture source. And even if I reopen the program that was closed, it's not going to automatically start capturing again. So I need to figure out a way to get it to actually automatically capture again. Otherwise, each time I run the scene, I'm gonna have to go into OBS and get it to uh, capture that game window again. I need to find a way to get it to. Oh, maybe I could write like a plugin or something for this specific source that makes it constantly check for a window named so and so. I could do that. Actually, no, I could do that. Yeah. Though I'll have to see to what extent the OBS API um, allows me to programmatically get it to, capture so and so a specific window, because it would be a different thing if it was just about pointing um, the capture itself to a specific. No, what am I trying to say here? Yeah, if it would be a different thing if the capture didn't have like multiple options. In this case, it's a good thing that the capture has multiple options, but the fact that the capture has multiple options being, either capturing the entire screen or capturing a specific window. And if you want to capture a specific window, more more specifically, a specific application. If you want to capture a specific application, you have to then select it from that list. So I need to find a way to do all of that programmatically. And then if I create a plugin, a simple like Python script or something, I can create a plugin and get OBS to get OBS to constantly check for this window. I don't know. I can set it to check like every like what 5-10 seconds or something. Yeah, yeah. Give me a second. Actually, let me hydrate and then I'll continue talking. Okay. All right. Let's continue with this. Now save your changes and run the scene. The sprite should rotate at a constant speed. All right, cool. That's what it is doing. Just a second here. Okay. Um, yeah. Okay, so we read this yesterday, launching the Godot application. Unfortunately, there's okay. Yeah, we read that already. We are well beyond Godot 4.2, so we don't have anything to worry about there. Okay, we now add a translation component to the sprite, following the upstream tutorial. What's the upstream tutorial? Complete script. Oh, okay, yeah. So after spinning, we go on to the moving. Why did they write it like following the upstream tutorial? Okay. Anyways, right. So we have the rotation code here. Actually, I I think the rotation code is here. Oh, we are getting the rotation as well. That's interesting. We are getting the rotation. Hold on. Are we able to get like? Are we able to get information on the functions that we are calling? Like for example, I did rotate here. This does not return anything. Okay. Down here we can do let rotation equals self dot base dot get underscore. Yeah, we have it here. Get underscore rotation. This returns a float 32. So this returns rotation in, I'm guessing degrees or radians, but like it's rotation on one axis, specifically the z axis, because we are sticking to 2D here. I wonder what 3D would look like. I guess it would change depending on whether the base type is 2D or 3D. Maybe. I'm not sure. Yeah, I wonder what the rotation function would look like in 3D. Let me just look this up. What was I going to look up? Godot. Godot, get 3D rotation. Get rotation 3D. Using 3D transforms. Okay. Okay, so what I'm assuming here is we are gonna get. Oh, does this return a quaternion like in Unity? Oh, I like that they're going into the sort of problem with Euler angles in the documentation. They're explaining why there's a need for it, and I think the idea behind quaternion was also to solve this problem. Another problem was something called the gimbal lock. I don't remember the specifics around it, but um, I think this demonstrates that. Okay, hold on. They are, oh damn, dude, they're going into full like full detail with this. Okay, transform functions, transform order, window transform, stretch transform, transform functions. Oh, this is great, dude. They are hold on. What is this a part of? I have to go under 2D and then see. Yeah, let me open that up here. So this is under manual, 2D, um, viewport, and canvas transforms. And they have like a bunch of very useful information here. Holy shit, dude! I can actually use this. As in use this information as I'm exploring Godot more and more. I can use this. I can use this information. Okay, moving forward, position plus equals velocity multiplied by delta. Why is the Rust code using the rotation then? Okay, velocity equals vector 2 dot up dot rotated. Oh, it's rotating where up is supposed to point. I'm assuming it's rotating where up is supposed to point, and essentially it's creating a direction in that way. So it's rotating where up is supposed to point by using the rotated function. Dude, that is so useful because in like okay, I would have never thought about doing it in this way. Actually, I don't think you had a way. There was like a simpler way, but it wasn't as simple as calling a rotated function, if I remember right. You could rotate a vector. I can't remember all the specifics around that because I haven't touched Unity C Sharp stuff in a while. But um, there was a there was like a tiny bit of math involved there. I'm trying to remember if there was. I mean, okay, you could create like a vector 3.1, and then I believe you could rotate. I can't remember if you could rotate the vector without having to do like matrix math. Let me hold on. Let me look this up because I'm curious now. Okay, in Unity, if I have a vector 3, a equals to okay, let's create an up direction vector. Um, is there a function I can use to rotate? I think there was transform.rotate, but then that rotates the object itself. I'm trying to remember if there was a way to rotate the vector itself. Like the vector is separate. Vectors can be used to represent a direction. In this case, the direction is up. So 0 on x and 1 on y. Or I think negative 1 on y, because I forgot if negative 1 is considered up here or like what's I'll have to look into that. But yeah, is there a function I can use to rotate this direction, quote unquote, to point elsewhere? In Unity, the short answer is yes, but you don't usually use a single vector 3 function. Instead, you use quaternions, and you use quaternions to apply rotation to your vector. Okay, since your vector 0, 1, 0 represents a direction, specifically vector 3 dot up, think of it like a physical arrow that you want to tilt or spin. The multiplication method, the standard way. In Unity, you rotate a vector by multiplying a quaternion by a vector 3. Important, the order matters. It must be rotation multiplied by direction. Okay, quaternion dot Euler. I guess that gives us the Euler angles, and then we multiply the vector 3 by, oh no, we multiply the Euler angles by the vector 3. The vector 3 is a, it's called a. The Euler angles are called, oh, they're not Euler angles. It's a quaternion. I just noticed the, okay, you guys can't see anything because I'm talking to Gemini on a different computer. I just remembered that. But yeah, it's a quaternion. So we are multiplying rotation, which is our quaternion, by um, the vector 3, which is A. All right, common ways to define the rotation. Look rotation, that was another method. Then there was angle axis. Okay, all right. Dude, this was really interesting stuff that I'd gotten into when I was first new to Unity. All of this, a bunch of the stuff comes under linear algebra. So like I was learning all about, um, I guess this comes under like Euclidean geometry in a way, because when we talk about a vector in Unity, or even in, I guess even in Godot for that matter, when we talk about a vector, these are Euclidean vectors. They're not vectors according to the math definition of a vector, because I remember this being a big confusion for me, and that this was also a confusion for other people who haven't studied game dev math before getting into game dev, which you shouldn't feel ashamed of doing that at all. Like everyone has their own journey. I definitely didn't know any sort of game dev math before getting into Unity, and getting into Unity and getting into game dev is how I actually got my excitement to learn math back again. Um, and then I learned whatever I needed to learn based on whatever I was coming across in Unity. And linear algebra was one of the many things. Vector math. Something that I liked was that these engines, they would really simplify the the process of doing the math, because they would provide you with all of these helper functions that could they provide you with higher level functions, basically helper functions that would make the calculations much easier for you. So you don't have to spend too much time worrying about the math behind it. You just have to call functions and do stuff. At most, um, you would need to do basic arithmetic stuff. And if you're trying to do something complex, maybe you could look into sine and cos and stuff like that. Trig functions, basically. What was I going to look up? Yeah, vector. Okay, it says here a vector is a mathematical or physical quantity defined by both magnitude and direction. This is where the confusion occurred, because there was, I think it was the direction. No, I think it was the magnitude that confused me. So okay, vector versus Euclidean vector. A Euclidean vector is a specific type of geometric vector, a directed arrow with magnitude and direction, typically used in 2D or 3D physical space. A general vector is a broader, abstract mathematical object within a vector space, which may include non-physical or infinite dimensional data. Hold on. Because something, okay, so once I got better at Unity, once I started exploring the math in there, um, it became clear to me. I can't remember all the details specifically, but like if you do your own research about this, you will also come across this. Um, there is a difference between like just a vector. If you try to learn the concept of a vector in math, the definition that you'll get is very much different from what you come across in um, in something like Unity, for example. Oh, you know what I could do? Okay. In Unity, a vector. Wait. When I learned Unity, I learned about vectors. I saw them being used to represent position, rotation, Euler angles, um, scale, direction, and more. But when I tried to learn what a vector is from Wikipedia, I remember getting what I'm assuming was the math definition of a vector. And that kind of confused me. I had a similar issue when I was trying to learn about tensors, because tensors, at least from a deep learning standpoint, from a deep learning point of view, from like a PyTorch point of view, essentially they're multidimensional arrays. But then when you try to learn about it from a math point of view, you tend to get a lot of different you tend to get like a different definition of what a tensor is, and that can be confusing for somebody who's not that deep into the math of whatever that tensor subject is surrounding. Okay, let's read what Gemini said. It is completely normal to feel a definition whiplash, okay, when moving from from game engines to formal mathematics. In Unity, a vector 3 is essentially a Swiss Army knife, a container for three numbers that the engine interprets differently depending on the context. Okay, so something I remember is that, okay, you have the vector, right? The vector can be used to represent a position somewhere in 3D space, and it does have a magnitude in the sense that it has a distance from the origin. But then direction, I think direction was something that confused me. A vector having direction. Yeah, I believe that's what confused me, because a vector in Unity can be used to represent a direction, but a vector itself having direction, that I think that's where I'd gotten confused. Okay, let's continue reading this. In mathematics, however, where okay, in mathematics, however, the definition is more abstract to ensure it works across all of science and engineering. The Unity, the what was that? The Unity container view. In a game engine, a vector is often treated as a data structure, as a position, a point in space relative to the origin, a scale, a multiplier for size, as Euler angles, degrees of rotation around axes. The unity way, quote unquote, focuses on what the vector represents in the inspector. Then you have the physics slash math arrow view. The math definition you likely saw on Wikipedia usually defines a vector as as an object that has both magnitude, which is length, and direction. Crucially, in math, a vector is not a fixed point, it's a displacement. If you have a vector v, 3 on x and 2 on y, it doesn't mean the point at 3 on x and 2 on y. It means move 3 units right and 2 units up from wherever you currently are. Okay, right. Then we have the abstract linear algebra view. Oh, isn't this basically using vectors as basis vectors? I think so. Hold on. Uh, this is this is usually where Wikipedia gets confusing. In formal linear algebra, a vector is simply an element of vector space. This means a vector doesn't even have to be a spatial arrow. It can be a color, a list of stock prices. Oh, as in like a container of some sort. Oh, you know what? Okay, they mentioned linear algebra. In matrix multiplication, a single row or a single column the matrix would also be considered a vector. Yeah. Okay, a list of stock prices or even a mathematical function, as long as you can add two of them together and multiply them by a number for scaling, mathematicians call it a vector. The bridge, why the confusion happens. The reason it's confusing is that Unity uses the same quote unquote box, vector 3, for two fundamentally different concepts, points, which is transform.position, and vectors, which is transform.forward. Okay, so points is for position, and then we have the direction, a direction and a push magnitude. Okay, why this matters for you: if you add 2 points together, the result is mathematically nonsense, whereas New York plus London. So that's okay, that's their example. But if you add a vector and a point together, you get a new point. Unity lets you do both with the same variable type, which blurs the line that math tries to keep distinct. Okay, all right. That's answered that question. Let's work on this. So here we are doing vector2 dot up multiplied by, no, vector2 dot up rotated. Okay, and then that is multiplied by speed. That is multiplied by speed. So doesn't that mean that it's just going to be moving in the direction? So, because like later on we do translate. The velocity being described here is being described with, um, like in terms of like a certain direction, isn't it? I think so. Yeah, yeah. The velocity is being described in terms of a certain direction. So then what's going to happen is, because we are rotating vector2 dot up to match the rotation of the object, and then we are multiplying that by speed, it should push the object forward in that direction. But then if the object keeps rotating, it's kind of going to end up in like a circular kind of motion, and I'm guessing that might be what we are going for. So let's do, yeah, let's just do that. Velocity equals vector2 up dot rotated, rotation multiplied by self speed. Dude, it is so helpful that we have IntelliSense here. It is incredibly helpful. Okay, velocity, right? Self dot base, uh, mutable dot translate velocity, multiplied by delta. I'm assuming that's to maintain a certain, that's to respect the frame rate as f32. Okay, that should be it. And now let me just, oh wait, yeah, I need to build as well. Um, okay, that's done. So now, let me just run this, and yeah, we have the behavior that I was describing. Again, you guys can't see it on stream. I still have to work on that because, um, the thing is, it says, wait, actually, are you able to see? No, you're not able to see it. Give me a second. Okay, let's try to move this. Oh, yeah, yeah, okay, okay. All right. Huh. Okay. Well, this is exactly what I was seeing. The result should be a sprite that rotates with an offset. Okay, custom Rust APIs. There's a bit to read here. Say you want to add some functionality to your player class, which can be called from GDScript. For this, you have a separate impl block. Oh, that's for a player alone. Okay. You have a separate impl block, again annotated with Godot API. However, this time we are using an inherent impl without a trait name. Concretely, we add a function to increase the speed and a signal to notify other objects of the speed change. Okay. Um, Godot API takes again the role of exposing the API to the Godot engine, but there are also two new attributes: func, which exposes a function to Godot. The parameters and return types are mapped to their corresponding GDScript types. Functions are elaborated in the functions chapter, and then we have signal, which is here. Okay. Um, oh, func is inside the impl block. I just noticed that. Okay, signal is also inside the impl block. This declares a signal. These are later explained in the signals chapter. Signals are, at least from what I remember, basically Godot's way of having like an event system. So you can like fire a signal and have a bunch of other nodes like respond to it. I don't know if I'm remembering wrong. I guess I'll find out once we get into signals, but this is what I remembered. It's like it's Godot's version of an event system. Okay, API attributes typically follow the GDScript keyword names, class, func. Oh, okay. I need to keep that in mind. I'm not doing GDScript, so like this is probably not going to help me too much, but then it's good to know because I need to add this to my code. Yeah, class, func, signal, export, var. Okay. Uh, that's it for the Hello World tutorial. The following chapters will go into more detail about the various features that Godot Rust provides. We recommend following in chronological order as important concepts are introduced along the way. Okay, dude, we made some good progress. Yeah, okay. You know what? That's going to be it for today's stream. Yeah, I'm going to end the stream here. I'm probably not going to raid anyone. Yeah, that's it for today's stream. I hope you guys have